Pardon? Okay, so we are now embarking on the second part of this paper 1 from November. We've got as far as question 9. We're moving on to question 10. So we're coming into the C into B grade questions. Question 10. A regular polygon has exterior angles of 45 degrees. How many sides does this polygon have? So the fact that you need to remember about polygons and exterior angles is that the total of all the exterior angles adds up to 360. And if it's a regular one, all the angles are the same. So to work out what the number of sides will be 360 divided by the exterior angle. So if they give you the number of sides and they ask you to work out the exterior angle, it'll be 360 divided by the number of sides, but the same rule applies in the other direction. So we have to do 360 divided by 45. It's not a nice division to do, but I'm looking at it and I know that 10 lots of 45 is 450. So I'm looking for a multiple which is less than 10. So I'm going to try, let's try 7. If I do 7 lots of 45, 7 5s are 35, 28, 29, 30, 31. So 7 is 315. If I add 45 to 315, I get 360. So if I do 8 lots of 45, just to be sure, 5 8s are 40, 4 8s are 32, and 4 36. So it's 8. So that's quite an easy thing to learn, polygons, that relationship between the number of sides and the exterior angles. Part B. Each side of this regular polygon is 7 centimeters. A sketch of 2 sides, A, B and BC of the polygon are shown below. Using only a ruler and a pair of compasses, construct an accurate drawing that shows these 2 sides of the polygon. The point A has been given. So the trigger there is construct. Basically it means you cannot use an angle measurer. You have to use a compass. So in the real exam, use a pencil in case you mess up. So from A, the first thing I need to do is to draw a 7 centimeter line. So on my ruler there, which I've got in millimeters, it would go to 70, or if I turn it around so I'm in centimeters, so that's B, and that is 7 centimeters. So the challenge is I've got to construct a 45-degree angle, which is one of the more horrible ones to deal with. Because first of all, you have to construct a 90 and then cut it in half. So to construct a 90, take your compass, open it out, doesn't matter how far, and mark on either side of where we're trying to draw the angle from. So because I want the angle to come from B, that's where my compass point has gone. Then move your compass to each side that you've marked, so each little pencil mark there, and you need to open it out so that it's more than halfway between where I am now and B, and draw above B, and then keeping the compass the same, I now need to go back to the other side to draw that. And that will be 90 degrees. So if I do a dotted line to show that, so that would be 90 degrees, but I don't need 90 degrees, I need 45. So I now need to bisect this angle, cut this angle in half. And if you've practiced this, if you want to bisect an angle, you would put your compass on the corner of the angle, mark one side of the angle that you're trying to bisect, then the other side of the angle where you're trying to bisect, then move your point to where you've crossed, and move your point to where you've crossed, and join the angle now by complete fluke. Okay, so that there is 45 degrees. By complete fluke, the 7 centimeter line, which we have to draw because it's a regular polygon, actually takes me on mine to where that cross is. Now that's a complete fluke. Could have been anywhere on that line. So that is point C. So it's quite quick to learn how to bisect angles, or to revise, how to draw a 60, how to draw a 30. That's one of the harder ones to do. But with a little bit of practice, on the website I've got lots of those construction practices where you can watch me do them. So for that, there's 2 marks for, well, let's go back to 10A first of all. 10A, there's a method mark for 360 divided by 45, and an answer mark for 8 sides. And for this, there's 2 marks for the 90 degree. There's 1 mark for bisecting it to get the 45. And then there's 1 mark if AB is 7 and BC is 7 as well, because it's a regular polygon, so that's 7 and that is 7. So if you can get your head around constructions, they're usually worth 4 marks or so. Question 11. The table below shows some of the values of y equals 2x squared minus 5x minus 1 for values of x from minus 2 to minus 4. So what they're doing is they're taking x as negative 2 and substituting it into that. So wherever there's an x, replacing it with negative 2 and working out what the corresponding value of y is. Now, when I teach this, the first thing I suggest you do is take the coordinate pairs they give you, because it'll help you figure out what that number might be around. So we're going to plot minus 2 and 17. So the x coordinate is negative 2 and 17 is up there somewhere, so we need to figure out the scale. It's going from 0 to 5 in 10 jumps, so every little square is going to be a half. So minus 2, 15, 16, 17 would be 4 squares above the thick line. That one I don't know yet, so I'm going to leave a gap. 0 is negative 1, so 0 is x, negative 1, 2 squares below it. 1 is negative 4. 2 I don't know. 3 is 2. And 4 is 11. Now, if you practice this, you will have already figured, oh, it's an x squared graph, so I'm either looking for a sort of happy curve or a sad curve. I can see from the points I've got there, this is going to be a happy curve. So when I work out that corresponding -1 value there, it's going to be somewhere around there, I would say. It's going to be somewhere between 5 and 10. So if I get it wrong, it should stand out. And similarly, 2 is going to be somewhere, I would say, around about -1, -2. So it gives me an idea of what I'm expecting. So x is -1. So into my formula, I've got the 2, and then where there's the x, I'm replacing it with -1, so it becomes a bracket. And it's also squared. Take away 5, instead of x, bracket, -1, take away 1. You work your brackets first. -1 squared means timesing it by itself. So what you've got is off the screen is that. So 1 times 1 is 1. When you're multiplying two negative numbers together, the answer is positive. The signs are the same. When you multiply or divide, the answer is positive. If the signs are different, the answer is negative. So that becomes 2 times +1. Take away, or here, well, let's just work that out. So 2 times 1 is 2. So that first part comes to 2. Here I've got -5 times -1. 5 ones are 5. The signs are the same. The answer is positive. So that becomes +5. And then we're not doing any multiplying with the last digit because there's no brackets. So I've got 2, add 5 is 7, take away 1 is 6, which is kind of where I was expecting it to be. So -1, 6. And then back up here for the 2. So y will be 2 bracket 2 squared, take away 5 bracket 2, take away 1. 2 squared is 4. 4 2s are 8. This time now, 5 2s are 10. I've got a negative and a positive. Signs are different. The answer is negative. So -10, take away 1. 8 take away 10 is -2. Take away another 1, -3, which again is kind of what I was expecting. So 2.5 minus 3. So if I had done something wrong there and ended up with 2 being down there, for example, then you wouldn't end up with that smooth curve. So you'd know you were wrong. So now you need to join those together. It should produce a curve, so you shouldn't use a ruler. And what I always say is to turn the graph around so your wrist is on the inside of your curve, because your wrist gives you a nice natural compass to draw curves. It doesn't have to be perfect. That's good enough. So make sure you use a pencil. So before we come off that page, so there's 2 marks for correctly working out those points, and then on the graph there's a P mark for correctly plotting all of those points, and then a C mark for a nice smooth curve going through them. So then we come to part C. Draw the line y equals 5 on the graph paper. Now y equals 5, the most common wrong thing to do with y equals is to draw it vertically because the y-axis is vertical. Y equals 5 means it goes through the y coordinate 5. To go through the y coordinate 5, it's got to be that way round. So that is the line y equals 5. So draw the line y equals 5 on the graph paper. Write down the values of x where the line y equals 5 cuts the curve y equals 2x squared minus 5x minus 1. So what they want here is what's the x coordinate at that point, and what's the x coordinate at that point. So reading off, I've got this in this direction, they're going up in 0.1s. So I got minus 0.8 and 3.4. Now your curve may be slightly different to mine, so they are allowed half a square out. So minus anything, minus 0.9, 3.4 for that. So one mark there for drawing the line. One mark for two values. So that's all you have to do for that mark, is to draw a straight line and write down the x coordinates where they cross. And then for the last part, this is very much a higher tier question, circle the equation below whose solutions are the values you have given in C. So total grade B question. What we've done is we've taken this curve, 2x squared minus 5x minus 1, and we want to know where it's equal to this curve, which is y equals 5. So y equals that, y equals that, sorry, y equals that means that that must equal that. But none of those options have an equals 5. They're all equal 0. So to make that equal 0, just like solving an equation, I've got to take 5 off. If I take 5 off that side, I have to take 5 off this side as well. And when I do that, I've got minus 1, take away another 5, takes me to minus 6. So 2x squared minus 5x minus 6 equals 0 is that one. So, as I said, definitely grade B for that. Comes up quite a lot, this, and as you can see, that carries 2, 4, 6, 7 marks for that question. It's quite an easy one to practice as well. Question 12, some probability. A fair six-sided dice and a fair coin are thrown together once. Circle the correct answer for each of the following statements. Okay, so before we do that, we need to consider all the possible outcomes from throwing a dice and a coin. So we could have a head on the coin and a 1 on the dice. We could have a head on the coin and a 2 on the dice. So if you remember when we were doing these listing possible outcomes, be systematic. So I'm fixing the heads and I'm considering all the possible outcomes of the dice. Okay, I've exhausted the dice. What can I change on the coin? Could be a tail and a 1. Tail 2, tail 3, tail 4, tail 5, tail 6. There's nothing else that could happen. So the number of possible outcomes is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The probability of getting a 4 on the dice and a tail on the coin is 1 out of 12. There's only one way you can get a tail 4 out of the 12 possible outcomes. The probability of getting a multiple of 3 on the dice and a head on the coin. So here's my head on the coin. Multiples of 3 are 3 times table. So that's 2 out of 12. But there isn't a 2 out of 12 in the list. But I can simplify that because 2 goes into both of those. So 2 out of 12 is the same as 1 out of 6, which is there. So 1 mark for each of those. Question 13. Okay, we haven't practiced this, okay, but if you can solve equations, it's the same rules. Okay, so if it says make the subject m the subject of the formula, I need to use the laws of equations just to leave the m on its own. So first of all, I'm going to get rid of the plus 7 by taking 7 off. If I take 7 off that side, I have to take it off the other side as well, which means the left hand side now becomes y take away 7, and the right hand side becomes 6m. Now to get the m on its own, I have to deal with the 6. It's a times on that side, so it has to become a divide, and in algebra we write divide as over. So we would write it like that. So to make m the subject, it basically means use your laws of equations to get the m on its own. So m is y minus 7 over 6, which you can write like that, or just to finish it off, so m equals y minus 7 over 6. Factorize, that's a trigger. It's the opposite of multiplying out brackets, where we need to put it in brackets. So you're looking to see what is common to that part and that part. And I can see 6 goes into that and that, so 6 is common. And also I've got x times x there, which means I can take one of those out. So I could write this as 6xx take away 6 times 2 times x. And then I'm taking out a 6x and I'm taking out a 6x. What am I left with? X take 2. And then just check you're right by multiplying it back out. So 6x times x is 6x squared. 6x times minus 2 is minus 12x. So you know you're right. Marks for that. So you've got 1 mark there if you get it down to y minus 7 is 6m. And 1 mark for the final answer. And here, 1 mark if you managed to take the 6x out. 1 mark for the correct stuff in brackets. Then we come to standard form, which again is something I haven't done with you. When you're working with standard form, it's all to do with place value. Okay, so it's all to do with, I've got my decimal point, and then I've got my units, then I've got my tens, then I've got my hundreds. Now, you know that 10 squared is 100. So I know that my hundreds column, I can write 10 squared above it. As I go Bigger than that, thousands would be 10 cubed, 10 thousands, 10 to the 4, 10 to the 5, 10 to the 6. They're just powers which enable me to write units, tens, hundreds, thousands, and so on. So sometimes it's this one that confuses people, 10 to the 0. Okay? Anything to the power of 0 is 1. So if you just think, right, standard form, I can write those out like that, 10 to the 0, 10 to the 1, etc., etc. What that means is 7.5 times 10 to the 6 means the 7 goes in the 10 to 6 column. So if it was 7 times 10 to the 6, it would be 7, 0, 0, 0, 0, 0, 0. Because it's 7.5, that takes up the space of one of the zeros. So this number I can write as 75 followed by 5 zeros. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. Over 5,000. And then when I'm dividing, I can just divide by 10 until I run out of zeros. So I can knock one naught off top and bottom, one more, one more. So that's the same as 7,500 divided by 5. 5 goes into 7 once, remainder 2. 5 goes into 25, 5, no remainder. So 7.5 times 10 to the 6 over 5,000 is 1,500. Now if I come back down here and write that in, 1,500 is that. So just like 7.5 times 10 to the 6 is written with a 7 in the 10 to the 6, that means that this number is 1.5 times 10 to the 3. Because the 1 is in the times 10 to the 3 column. And we can do the same thing with part B. So with part B, I just go to a different colour. I've got 2.3 times 10 to the 3. So the 2 is going in the 10 to the 3 column. 6.4 times 10 to the 4. The 6 goes into the 10 to the 4 column. And they want me to add those two numbers together. So I got 0, 0, 3, 6, 6. Which is in the 10 to the 4 column. So it's going to be 6.63 times 10 to the 4. Because this is in the 10 to the 4 column. So if you just remember to write those list of powers, starting with 10 to the 0, that's how you do it. Grade B. This is something else we haven't done. Simultaneous equations. So each side of a square is of length 2x plus 3y centimeters. The perimeter of the square is 62 centimeters. So from there to there, plus there, plus there, plus there, all adds up to 62. So because it's a square, they're all the same length. So one side of the square is going to be 62 divided by 4. So 462, 4 goes into 6, once remainder, hang on, sorry, yeah. 4 goes into 6, once remainder 2, 4 goes into 22 5 times, but with a remainder of 2. So we put the decimal point and add a 0, 4 goes into 20 5 times. So that means each side of that square is 15.5. And I know the square has got a side 2x plus 3y. Then I look at the octagon, and the perimeter of the octagon is 72, and there are 8 sides. So 72 divided by 8 is 9. So for the side of the octagon, I've got the side is x plus 2y, and that's equal to 9. So when you solve simultaneous equations, we've got two unknowns, an x and a y. And we've got two equations. So if I rewrite those, so I've got, what have I got? 2x plus 3y equals 15.5. That's equation 1. X plus 2y equals 9, which is equation 2. So this is doubly complicated because not only is it simultaneous equations, which we haven't done, but also it's out of a problem. Okay? So there are marks for getting it down to there. Now the method for simultaneous equations is to do something to make these x terms the same so I can get rid of them. Okay? Now I'm going to do that by taking this second equation and timesing it by 2. So if I take equation 2 and times it by 2, I get 2x plus 2 lots of that is 4y equals 2 lots of 9 is 18. So I'm going to call equation 3. So to make the x's go away, I'm going to subtract. Okay, I'm going to do equation 3 take away equation 1. So 2x take away 2x is nothing, it's gone. 4y take away 3y is 1y. And 18 take away 15.5 is 2.5. So y is 2.5. Then I've got to work out what x is. So now that I know what the value of y is, I can replace the value of y in there by 2.5. And what I say then is I sub in equation 2. So x I don't know, plus 2y is 2 times 2.5 equals 9. So x plus 2 lots of 2.5 is 5 equals 9. So x is 9 take away 5, which is 4. Very much a higher tier topic. The grade B class might have done that, but I haven't gone anywhere near simultaneous equations. So the mark scheme for that. So there's 1 mark for getting that equation, 1 mark for getting the other equation, a method for eliminating to get y equals 2.5, and 1 mark for the other value, which was x is 4. So I really wouldn't worry at this stage about simultaneous equations, mate. All right. But the next topic we have done, probability trees. So Alwyn often drives from Bangor to Cardiff. He always chooses one of 2 routes for these journeys. He either travels through Rhyadr or through Hereford. The probability he travels through Ryder is 0.7. Sometimes he decides to stop for a break during his journey. His decision is independent of the route he takes. The probability that he travels through Ryder and stops for a break is 0.42. Complete the following tree diagram. Alright, so we've practiced these. You know that the branches need to add up to 1, so you know that that there is going to be 0.3. Then there comes the trap with this particular question. Because if you don't read it carefully, you want to put 0.42 there. But 0.42 is if he's Ryder and stops. It's the outcome of that probability and that probability. Now, when you revise tree diagrams, what will come back to you is that when you move in the same direction and you use the word and, it's multiply. So what we're saying here is 0.7 times whatever that value there is equals 0.42. So go through your 7 times table. 7 6s are 42, so that must be 0.6. So you need to watch out for that. More often than not, they don't give you that, they give you that, and then filling in the tree is easy. But you've got to be careful with that. Once you know that is 0.6, these two have to add up to 1, so that's 0.4, and that means this is repeated down there. B. Calculate the probability that Alwyn travels through Hereford but does not stop for a break. So he's travelling through Hereford and not stopping for a break. So we're travelling in the same direction, we're multiplying. 0.3 and no break, 0.4. 3 4s are 12. 2 numbers after the decimal point. 2 numbers after the decimal point in the answer. So, marks for that. There's 1 mark for the 0.3 there. There's a method mark for you recognizing 0.7 times something equals that. And an answer mark for 0.6. And then a final mark for finishing off all the gaps on your diagram. And then a method mark for 0.3 times 0.4. And an answer mark for 0.12. So probability trees come up every year, every season, sometimes on paper 1, sometimes on paper 2, but it's really worth going back, looking over your notes for that. And then we have the final question, which is grade B again. Something else I haven't really done much with is inequalities, but we have touched on it. William has n marbles. Lois has 4 times as many marbles as William, but she has now lost 23 of them. Lois still has more marbles than William. Write down an inequality in terms of n to show the above information. Okay, so William has n marbles, Lois has 4 times as many. Well, 4 times n is 4n. But she's lost 23, so she's got 23 fewer. So the 4n comes from 4 times as many. She's lost 23, so she's lost 23. So if she had the same number as William, we could put that equal to his number, which is n. But because we know that Lois has got more, I know that that value is greater than n. Once we got that, pretty much the intermediate tier, it now follows the rules of algebra, solving equations. So I want to take n off that side and n off that side, which will leave me 3n take 23 is greater than 0. Now I want to add 23 to both sides to give me 3n is greater than 23. Then to get the n on its own, I have to divide by 3. So I get n is a bigger number than 23 divided by 3. Now if you want to turn that into a mixed number or into a decimal, 3 goes into 23 7 times, remainder 2 out of 3. Okay, so you could write it as a fraction like that, or you could do 3 into 23 goes 7, remainder, whatever it is, 2, 3 into that goes 6, and so on. The important thing is to see that there is 7 point something. So n has to be bigger than 7.6. And because we're talking about marbles, you can't have 0.6 of a marble, so we must have 8 marbles, or the fewest marbles he must have is 8 marbles. So use your inequality to find the least number of marbles, in order for that to work. So that one, actually, you've got a chance of getting some marks out of that more than the simultaneous equation one. So there's 2 marks for that line there, that inequality, and then 2 marks for getting down to fewest marbles, 8. 1 mark for getting that, 1 mark for getting the final answer. So that's getting them all right. You remember, you don't need to get them all right.